David Futransky, Senior Director of Institutional Advancement at Evanston Township High School, and a member of the class of 1969 from ETHS. And I want to welcome you to another version of Coming Together. Today we're talking about space, the final frontier. To quote from Star Trek, to go where no man has gone before, or maybe to say no man or woman has gone before. We have a discussion among some of our alumni who work in the space industry. Michael Werner from the class of 1959, Faith Vilas from the class of 1969, and Julia Crowley Ferenga from the class of 2012. They're going to have a discussion about space, what got them interested in space, and what they're doing, which revolves from telescopes to planetary science to landing a rover on Mars about a month ago. The host and moderator today is Matthias Shelbert. He's from the class of 1990, but he also is one of our teachers, member of our faculty at ETHS, and he teaches astronomy and astrophysics. He's the perfect guy to lead this discussion. So, Joan, take it away.
Hello, everybody. My name is Matthias Shelbert. I teach astronomy and astrophysics here at Evanston Township High School, but I am also an alumni, and I'm very excited to be here today with other alumni, because the people that you see here in this panel are alumni from ETHS who work in the field of astronomy and astrophysics. And we're very excited to share with you their story, their history, and where they're going, and what astronomy is doing today, and how ETHS is helping carve out our understanding of the universe. And so what I'd like to do is let's start out with Dr. Werner. Let's ask who you are, what you do, and what year you graduated from ETHS. Dr. Werner?
My name is Michael Werner. You can call me Mike. Dr. Werner is a mythical person I've never actually met. I graduated from ETHS in 1959, which was a long, long time ago. For the past 50-odd years, I've been associated with a NASA project called the Spitzer Space Telescope. It's a counterpart to the Hubble Space Telescope, working in the infrared part of the spectrum. I hope we'll get into that later. I've been the project scientist or the chief scientist for all these years, and I work at the Jet Propulsion Laboratory, partly retired, so I like to describe myself as a semi-retired rocket scientist, and I'm delighted to be here.
Great, thanks for joining us here. Faith?
Yes, my name is Faith Vilas. I graduated from ETHS in 1969 and went off to study astronomy, and somewhere in there fell in love with planets as well, so I went into planetary sciences, but as an observational astronomer. So my career has sort of been split between working with the telescopes on planets and asteroids, and also working with spacecraft missions to planets and asteroids. I worked for NASA for over 20 years at the Johnson Space Center, and then I went off to become the director of the MMT Observatory in Arizona for 5 years, and after that have been spending my time doing research with the Planetary Science Institute, which is a private planetary science space institution with about 105 planetary scientists at it. And I've been there for on and off for many years, with a brief stint at the National Science Foundation in Washington.
Wonderful, fantastic. And finally, Julia.
Hey everybody, I'm Julia Crowley Ferenga. My pronouns are she, her, hers. I graduated from ETHS in 2012. I also work at the NASA Jet Propulsion Laboratory in Pasadena, California. In school, I studied aerospace engineering, so I'm less on the science side, but I work on building and testing the engineering hardware, the spacecraft, the rovers, as you can see behind me, that allow the scientists like Faith and Michael to do the science. So I've been at JPL for about 2.5 years. Most recently, was working on the Mars 2020 rover, which hopefully everybody saw land on Mars on February 18th. quick plug, we're hoping to see the Ingenuity helicopter's first flight in a couple days. So we're all really excited for that. And I'm now working on the Psyche asteroid mission at JPL.
Wow, it's absolutely amazing. So first of all, thank you again for joining us here, because one of the things that I really look forward to having this presentation and this panel do is to inspire. And speaking of inspiration, I want to ask each of you, what was your inspiration? What was that aha moment where you said, you know what, astronomy and science and engineering, that's where I want to go with my career? And more importantly, if you can, how could you integrate ETHS with that kind of feeling? And that's like, for me, what I can say, because I am an alumni, so I'm going to jump in here as well. I remember sitting in Mr. Davis's class in 1989, taking my very first physics class. And the light bulbs that went off every day in my head said, this is what I want to do. And with that, I got my degree in physics. I worked at NASA working on the pre-Kepler mission in Mountain View, California. And I had a calling to come back to ETHS to give it to the next generation. But it was definitely Mr. Davis, my physics teacher at ETHS, that really planted that seed for me. And so let me do this kind of in reverse order. So Julia, why don't we start with you and ask you, what was your inspiration and how did ETHS get integrated into that process?
Yeah, well, as you were sharing your story, I just had to nod along because that's kind of exactly my story too. I remember it was sophomore year physics with Mr. Dubrowski, chem phys, learning about, of all things, friction. And it just kind of clicked in my head and it stuck. And I was like, I love being able to explain kind of natural phenomenon and what's going on in the world with math and science. Now, I don't love math. I can do some math. I don't hate it. I don't do it all day, every day. In fact, I hardly do any math at all. But I liked being able to use math and numbers just because they kind of stuck in my brain better than like historical facts. But yeah, it clicked for me in physics. And ETHS is inseparable from the rest of my career. I really owe so much to ETHS. Starting sophomore year Chem Phys, I continued in Chem Phys junior and senior year with Doc B and Doc K. And it was after junior year, I participated in a sort of a summer camp at actually NASA Johnson Space Center. And it was thanks to Doc V for nominating me for that. It was actually planning a human Mars mission. It started as an online kind of class. And then if you got a high enough grade, you got to go to Johnson for a week and tour the facilities. And that was so cool. I saw Robonaut, this astronaut robot, and I was so interested in robotics and all of the engineering that goes on there. And then also that summer, also thanks to Doc V, I participated in a research project at Northwestern University in astronomy in post-starburst galaxies, which I then, along with my partner Patrick Loftus, we submitted to the Siemens competition in math, science, and technology. So we wrote up a paper, did a presentation. We got to present at MIT, which I later went for undergrad, and I think it was a huge part in my admission to MIT was that presentation. And then we also got to present at George Washington University. So it is all from ETHS and can really trace where I am at NASA JPL now from that sophomore physics class.
That's fantastic. And Dubrowski, he was my mentor my first year at ETHS. So
oh, wow.
Dan and we go way, way back. So he'll be very happy to hear this as well.
I called it. I called him the wrong thing.
No, you didn't. Not at all. Faith, how about you?
Oh, my story started a little earlier than ETHS time in my world. I was a sophomore. I was in second grade, and I was given a copy of a book called The Golden Book of Astronomy, which way back when was a long time ago. It was before we had astronauts in space. We were sort of coming up on them. And I kept looking at this and looking at the planets and looking at everything and said, this is what I want to do. And so mixed with a couple of other passing thoughts on into high school, this is still what I wanted to do. So I got to ETHS, and there was an astronomy club, and there was the Chem Phys, track, which I took at the time. And I go back to advanced Chem Phys with Mr. Anspaugh, and chemistry in the first year with, and I've forgotten his name, but I know he's been back to ETHS to visit. But anyway, with Mr. Anspaugh, and that altogether inspired me to stay in astronomy. I participated in an NSF program for students on the weekends down at the Adler Planetarium. And then the planetarium that we have now at ETHS, that you have, was first being built in 1967-68. And I talked my way into a job with the Adler when I was in high school, so I could learn how to work with planetariums. And I wanted to come back to ETHS to operate the planetarium, which maybe I did a little bit before I left because I graduated in '69 and went off to major in astronomy at Wellesley College, which has a very good undergraduate astronomy program. But I also wanted to do planetary science. Somewhere in there, I realized that the cross between astronomy and geology was where I wanted to be. And the only planetary astronomer around was at MIT. So in fact, I went over to MIT as an undergrad to do research and take some courses there in that topic and stayed there to get my master's degree. So, and then I wanted a break from astronomy and took off. But a lot of the my incorporation into the field of astronomy at the beginning was during ETHS. Now, I won't claim to be the world's best physics student, so I, sort of fought my way through Chem Phys, but I survived and went on to get my PhD in planetary sciences. So.
No, that's fantastic. And, it's funny that you say, that physics didn't really speak to you. While Julie was in the Chem Phys program, which is, nationally renowned as being like the cream of the crop, I took regular physics, and what I always say, it's not that level has to do more with the pacing, right? It was at the pacing that I could actually learn and absorb and let my inner scientist grow. So, by any means necessary, however we get there is how we get there. So that's great. Mike, how about you? What got you into this field, and how did ETHS help you in that?
Well, thanks very much, Jim. Or Jam or John, whatever it is.
John.
Yeah, just a couple of comments on my fellow panelists' comments. Julie is an example of something which is quite prevalent at JPL, which is that young people get a tremendous amount of responsibility if they're capable of carrying it off, which I'm sure she is, and that's a healthy thing for an institution. And like Faith, I was inspired to some extent by, I guess Robert Anspaugh was his name, is that right, Faith? Who was a very charismatic physics teacher, famous for long ties and playing chess. So I got to know him quite well, but I can't honestly say after all these years that I can trace my subsequent activities and successes back in any way to ETHS. So what got me started on my career actually is the following story, which is true. It sounds kind of corny, but I went off to college called Haverford College, which is a small liberal arts school near Philadelphia. And I had originally wanted to be a doctor, and I sort of drifted away from that. I was majoring in physics, and like many other colleges like Wellesley, I'm sure, Haverford had a little observatory. And there was one astronomer there, a man named Lewis Green. He taught some physics courses in the classroom in the observatory. So we used to go over there when I was a junior to study mathematical methods of physics, which is a whole separate story. And one day, as I was leaving the classroom, I walked through the library, and there was a book there on the counter called Frontiers of Astronomy or Problems in Astronomy by someone like Fred Hoyle or George Gamow, or some book that presented astronomical questions at a comprehensible level. Some of the same questions we're wrestling with today, I might add. And I picked it up and said, astronomy, that's kind of interesting. I've always been interested in astronomy. Now I'm going to make this up. If I had to do it over again, I'd be an astronomer. But wait, I'm only 19. So anyhow, literally, I took that book home and read it back to my dorm. And that started me off on my career as an astronomer. An important thing along the way was that because I hadn't studied a lot of astronomy as an undergraduate, not that that's necessarily important, physics is more important, I wasn't quite ready to go to graduate school. So I took a year off and went to work at the U.S. Naval Research Laboratory, where they had one of the first space research programs, which began parenthetically with captured German V-2 rockets from World War II were being used with instrumentation, to do ultraviolet studies of the sun. And while I was there for that year, I met a wonderful man named Martin Harwit, who was a professor at Cornell, and he talked me into going to graduate school at Cornell, and things went well thereafter.
No, that's fantastic. And, it's funny because, I told you my inspiration was my physics class. Well, here I am teaching astronomy. How'd that happen? And I never even thought about astronomy, and it just fit in my schedule as an undergrad. And after the first day, I was like, whoa. And I looked forward to every day. And then Dr. Tomley at San Jose State, he's the one who got me inspired and said, hey, go into astronomy, go into physics and everything like that. And, one thing I love is all four of us have actually had different paths that brought us to the passion of what we love, which is science. Which kind of leads me to my next question for you. In today's kind of culture, there's almost this like science versus anti-science bubble that exists here in our country and maybe even around the world. And so I kind of want to ask you guys, why is space exploration and astronomy important today, right? In the 21st century? What do you think? Mike, do you mind if I start with you? I'll just kind of go back around on that.
Well, I think first of all, of course, it's exciting and interesting, and it's part of man's kind of quest to understand the world. It's important to realize that even when you talk about a space project, the money does not go into space. The money is spent on the Earth, developing people's engineering and scientific capabilities, supporting our aerospace industries. When we worked on the Spitzer project, we had a big contract with Lockheed Martin, and at a facility where most of the work that was being done was classified. And so the people who worked on our project, which was not classified, were delighted by the fact they could actually go home and talk about it. So there's that kind of aspect, building our industrial base. It's also a very good training for future work. A PhD in astronomy, particularly modern astrophysics. Often people will leave graduate school and go on and do something totally different after they get their PhD, which is fine, but they've learned techniques, they've learned skills, capabilities. Maybe they're working in data sciences, maybe with computer hardware and so forth. But I think more directly, and you mentioned this earlier, astronomy is a great vehicle for science education for people who are interested but not necessarily up to date or technically very well trained. The questions that you deal with in astronomy, like is there life on other planets? What is the fate of the universe? Is there water on Mars? Are there other planetary systems and so forth? These are very accessible to the man in the street. And I think it's something that motivates all space scientists to leverage that accessibility as a step towards scientific literacy. And we see that at JPL. Faith may have had similar experiences. Julia probably has been there. We have these open houses every year, and they're just packed. Tens of thousands of people walking around our facility, having little Mars cars run over their tummies, seeing the clean room where spacecraft are being assembled, et cetera. It's really, really heartening. And it doesn't reach all of the people, and maybe the ones who are most skeptical about science are the least likely ones to show up at our open house. But at least it indicates that there's a wedge, there's an opening there that we're taking advantage of.
No, great. Faith, what do you think?
Based on your original question, my answer or my sense of this has always been that it is humankind's need or part of our drive or part of our being that we seek knowledge beyond where we are now. And science is that type of thing. It's going to be real, whether or not we have agreed that it's real or not. Whatever is out there is going to be taking place. We don't change it by the fact that we would say, oh, I don't want to study science or I don't believe in science. I think that humankind, for going for astronomy or planetary sciences, it's our inherent curiosity about these topics that drives us to want to continue to explore. It's part of what is wonderful to me about being a scientist is I can satisfy my curiosity. Oh, here's a new problem. Oh, I can take a look at it, and how best can I approach it? What's the best way that I can do that? Can I see a connection between this and some other issue that's come up in planetary sciences? Is there a way to relate these two? I love the diversity. I love the fact that I'm not necessarily constrained by my thoughts, other people's thoughts. We can just keep on looking at things. And it's very concerning to me that people have decided that they do not want to believe that science is real, and that they come up with alternative ideas for why science can't be real. We're going to find out what's real or not with time anyway. Science is constantly being revised. My favorite example of that is the planet Pluto, which I think it's a planet, because I went to school and learned about it in grade school when it was a planet. These days, the International Astronomical Union has rededicated it to being a dwarf planet, and that has a lot of people unhappy in some directions, and other people are perfectly happy with it being a dwarf planet. The takeaway from this is that science is constantly evolving. Science is not static, and that we have discovered when our technology caught up with the size of the solar system, when we could see beyond Pluto's orbit and start seeing that there were multiple other objects out there, the Kuiper Belt, other now called dwarf planets, then we see that the solar system is much larger than we expected it to be. And we're just catching up with what's out there. And it's that science is ever evolving. Science is not static. It never will be, I don't think. And I love that. And I wish other people would understand that, because the scientist says, no, we've changed our mind. This is not correct. This may be correct over here. In whatever field of science they're talking about, they're looking at just the ever evolving nature of science. Some things are going to be wrong, but that's part of what science is. You have an idea, you test it, looks good, keep testing it with more data. Looks like it needs to be adjusted, you adjust it. If it doesn't work anymore, oh well. But that's part of the fun of it.
Yeah, no, absolutely. And the analogy I always use in my class, because I always have students same way. Why did they do that to Pluto? Like, okay, let's talk about that, right? When Pluto was discovered, there were 9 planets. It's like, imagine if you had a closet of shoes. You have 3 pairs of shoes. Do you really need to organize them? No, you can just call them shoes. Well, now we have over 4,000 planets, right? Imagine having 4,000 pairs of shoes. Can you just pile them in and say, here are my shoes? You have to start categorizing them and classifying them to gain that better understanding. So I really appreciate that piece that you're kind of bringing up here. Julia, what's that?
Oh, go ahead.
No, I was going to say, Julia, you're kind of newer into the professional science field. How do you see your outlook as far as the importance of science and astronomy in the 21st century?
Yeah, well, I also want to echo some of what the other panelists said. I, too, am concerned about some anti-science sentiment, and I think that's why non-science classes, as counterintuitive as it may sound, why non-science classes are so important, because they help you develop critical thinking and ways to approach problems from different angles, and it gives you different contexts in which to view the world. And I, not just ChemPhys at ETHS, but I think all of the other classes really helped me develop critical thinking skills. So even if folks don't study math and science, it's really important to invest in education so that the population has critical thinking skills that can help them evaluate, truth and what's real and what's not. I also remember in the physics classes learning about how the model of the atom has changed throughout time. And that's just another example of how, science is guided by evidence and what we can prove. And so if we have an idea about the model of an atom, like a muffin with raisins, and the evidence doesn't support that, well, okay, we have to change it. And so that's also one of the beautiful things about science. Other reasons why space exploration is important nowadays, well, okay, it's really cool. I studied aerospace engineering in undergrad, and I did my master's at Purdue University in rocket propulsion, because rockets are super cool, and I love seeing all of the smoke and the fire. It's really fun to, start with model rockets, build your own rocket, which I wish I started in high school, but I didn't start till college. It's just really exciting. And even if it doesn't work and it blows up, that's also pretty cool. So you can inspire, the future generations just by watching the satellites being launched into orbit. There's so many cool, I also really loved going to the Chicago Air and Water Show. I love seeing the Air Force Thunderbirds or the Blue Angels. I thought that was really cool. I wanted to go work in the aircraft propulsion field and work on jet engines. But then I realized, well, rocket engines are bigger and way more powerful. So yeah, I want to work on those. Space exploration is important just for that fact that it's beautiful and exciting. Also, there are a lot of Earth observing missions that are going on right now, a lot from JPL, in fact, and they're crucial for helping to understand climate change and the climate change problem that we're seeing, and helping humans identify the impact that our lifestyles are having on the planet. We can, take crazy detailed pictures from space to show, look, this lake has dried up over this amount of time. We can see all of the massive wildfires that we had in California in the fall. And so it's not just looking, outwards towards the stars, but looking at our planet in ways that we can help save it. And then also, one of the things that actually I was part of that class that I took at Johnson Space Center was spin-off technology. A lot of the technology, some of the most advanced technology we use every day and on Earth, came from the space program. Tempur-Pedic mattresses, a lot of our cell phone technology and GPS, which I would be lost without literally, is possible because of the satellites and space exploration. So again, even if people don't believe in science, well, they can thank science for having their cell phones and other things that we couldn't live without. So if we, just by developing and operating a space mission, we will get innumerable returns from that mission on Earth.
Yeah, no, go ahead, Michael.
This is Michael. If I can just expand a little bit on something Julia said. Julia, you might remember that at the time of the Perseverance launch, Rob Manning, who was sort of the color commentator, kept on hitting upon the fact that the success of Perseverance shows that people can do things, that we were capable of accomplishing things. And we had a kind of you probably saw it, a private session with President Biden, who was congratulating the Perseverance team. And he said that this is an example of American ingenuity and American know-how. But leaving the politics aside, the space program is a kind of a beacon pointing to or facilitated by our better selves. That Rob said it very well. When I talk about the Spitzer Space Telescope, I like to say that it's an example of the best that a group of people are capable of doing if they're properly empowered and properly supported. And I think the space program, in particular the robotic program, with the great success of missions like Perseverance, the Hubble Space Telescope, Spitzer, and so forth, is really kind of almost a North Star that we should all be pointing to as exemplifying the most positive things about the human spirit.
Yeah, it's funny, Julia, you kind of mentioned model rockets, right? And good news is, so we have actually a newer course called Astrophysics at ETHS. It's a second-year astronomy course that integrates basically math, physics, astronomy, and computer modeling in Python, all into one class. And one of the things that I do, so hopefully you'll be proud of this, is that I have students write in Python a computer model to predict where a model rocket will land. And so we give them the data of the engine, they have to build it, they have to weigh it, and then I have a little altimeter reading. And when we didn't do it this year because of COVID, but when we did it last year, my students consistently got within 10% of their projected landing site. So, you know, that kind of inspiration, Michael, what you're talking about is, you know, we're trying to plant that here at ETHS now, which is awesome. The other thing I actually want to kind of touch on real quick is that, you know, our students are very, very tuned into social justice and science. And a lot of them are struggling with this kind of, I think this is the right word, but the dichotomy between we see Perseverance landing, yet we see all this strife among humanity. How does one come to terms spending, you know, billions of dollars going into space when we have people who are hungry, right? And it's a very interesting conversation to show. And Michael, like you set up in the beginning, you know, money that goes into space programs, almost none of it goes into space. It all gets trickled down. And just as Julia talked about, you know, Neil deGrasse Tyson says, I got one word for you, lasers, right? Lasers were created by science. And there was nothing that has increased our economy, our funding, than that. Same thing with the internet. And so, you know, it's not an either or, you know, it's a this and that. And Julia, like exactly like you said, the humanities programs that we take help us kind of counter that constant science piece to that. So anyways, I just thought I'd kind of throw that in there.
Yeah, could I actually hop in and say, that class sounds amazing. I wish I could have taken that. I used Python. We use that primarily in my job at JPL. And I didn't learn it until after grad school, until I was on the job. So that would have been super helpful. And that project also sounds a lot like the rocket team that I participated in at MIT. So that's awesome. Students are getting a huge head start, and that's so cool. Rocket team was one of my favorite things. And honestly, when I go back and talk to the rocket team and other extracurricular groups at MIT, I say that the most valuable part of my education wasn't exactly in the classroom as what I did with what I learned in the classroom in those extracurriculars. And when I was applying for jobs and internships and stuff, everyone wanted to know, what extracurriculars are you working on? And that was the hands-on experience in applying what was learned in the classroom was what was most, I think, beneficial for me. And it's super fun. Launching rockets is cool. I also, yeah, and in the, not just like my friend group at JPL, but I think social justice is quite prominent in the science community. A lot of scientists and engineers are also pretty active in seeking social justice. And if folks aren't aware, the NASA Artemis program to return astronauts to the moon will seek to land or send the first woman to the moon and the first person of color, which is great. It's about darn time. And hopefully that inspires more people who aren't typically interested in or involved in science, because it's so impactful just to see somebody who looks like you doing, you know, things that you've never seen them do before. It's so impactful. So it's tied into social justice and other, earthly challenges are tied into science and space exploration as well.
No, for sure. It's not either or, it's this and, right? It's the confluence of everything. One thing I like to ask is, what are you guys working on now, right? I know, Michael, you just finished an incredible bout with the Spitzer telescope. I'd like to hear about that, and then kind of what you're working on. And so I'll start with Michael, go to Faith, and then to you, Julia.
Thank you, John. Very quickly, the Spitzer Space Telescope was decommissioned at the end of, basically in January of 2020, after a earth-shattering 16-plus year mission. I'm working on a paper which, although Spitzer was most known as a scientific instrument, and the science is described in this book that I wrote with one of my colleagues, More Things in the Heavens, available on Amazon if you're interested. I recommend it highly. But I'm now working on a paper which describes some of the technical innovations of Spitzer, which will be of interest to future generations of mission planners, because we did a lot of unusual things. Because we operated in the infrared, we wanted to be cold, and previous missions had gotten cold by carrying a lot of refrigerant. We got cold primarily by going far from the Earth into an orbit around the sun and using what's called radiative cooling, where you lose energy into the cold blackness of space. And that accounted for a lot of our success in our long lifetime. So writing that technical paper is one thing I'm working on. In addition, I'm involved with the new NASA mission, although in this case I'm just a rather humble member of the science team as opposed to a leader. That mission is called SphereX. In the best tradition of NASA, we have a logo. That's my SphereX logo there. And SphereX is a small mission. It's what's called an Explorer, and headed by Jamie Bach from Caltech, JPL. And we'll be getting spectra across the entire sky in the visible near-infrared, studying several different scientific problems and creating a database as a legacy for future explorations. So those are the two things I'm most involved with at the present.
Oh, that's fantastic. I really look forward to stuff. The LSST, I forgot, they renamed it.
The Rubin.
Yeah. That's kind of in the same vein that they're going to be doing a 10-year survey of the entire night sky. And their goal is to have it all available and open to the public for kind of exploration of the data itself, which is kind of exciting. So, Faith, how about you? What's taking up your time these days in the world of astronomy?
Well, first, I have to say I share with Julia this love of power. Watching the rockets launch, and the bigger the rocket launch, the better. I just love it. But that's neither here nor there, because for some reason, although I wanted to go pretty fully into the space program, I've found myself trading time between both ground-based astronomy and space-based astronomy, although and my personal research has been in planetary sciences pretty much. So what I've done has split that time between ground-based observatory directorship. Probably a lot of the work at the NSF that I did benefited from that. But also I've been involved with some of the planetary science spacecraft missions like Messenger to Mercury. And currently I am on the Lunar Reconnaissance Orbiter LAMP, which is the UV Lyman Alpha team, looking at UV characteristics of the moon. So I've sort of gone a different direction than Michael in that I've gone to shorter wavelengths and both the UV and the visible. I'm as intrigued by the description of the instrument that you just talked about, SphereX, going visible near infrared, since I've looked at reflectance spectra from asteroids. And the types of things that the results that I've had primarily have been related to visible UV and very near IR spectra, which is different than a vast majority of people. And I've combined the two. I've used a lot of ground-based astronomical work to support space-based work. Maybe the best example of that is that some of my ground-based spectra of the asteroid Ryugu, 162173 Ryugu, which is what the Japanese Space Agency has just captured a sample and returned to Earth. A sample of Ryugu was based on some spectra that I took with the MMT years ago. For when it asked, can you look at this particular object? I said, sure. And some things I did see and didn't see in the spectra. And some of that has panned out and some of that hasn't, but they certainly have gotten fabulous information. And I'm not the only person who observed it, certainly before they went. And there were other constraints like its availability with dynamically available to a rocket from the Earth or a satellite from the Earth. So, but ground-based astronomy has played into its space-based results, which then turn around and feed into ground-based astronomy further. So there's some synergy between the two of them. And that's where I've kind of landed. And it's surprising to me that I did, but I've always loved ground-based telescopes and going to the telescope as much as I've loved the space-based work or the satellite work. And so that's where I am right now, which is sort of having been at the NSF for 3 years. I'm back doing my research, and I'm also editing a new journal. I'm the first editor, the inaugural editor of the Planetary Science Journal, which is an American Astronomical Society journal. It's dedicated to planets, exoplanets, anything related to planetary sciences, which I believe encompasses exoplanets, which I think are truly, truly amazing and might be where I would have gone if I'd been in the whole system 40 years later. But I'm not. I'm here where I am. And so that's kind of what I'm doing right now, is somewhere between still involved with missions, my own ground-based work, which is a lot of data reduction at the moment, and working with the journal, the editing the journal right now. Sooner or later, Joe, I'd like to put in a plug for not necessarily feeling that you have to go through graduate school or college to graduate school to PhD-hood, or post-PhD-hood or whatever, that it's worthwhile to take time off and work, like Michael talked about. And I did the same thing earlier and spent a couple of years at an observatory in South America back in the 70s, and then worked for a year for Lockheed, and then went back for my PhD, and it allowed me to be very focused about what I wanted to do at that point.
Yeah, it's funny. My father was a professor of history at UIC, and I remember him saying, son, opportunities come and go, but school will always be there. And that cannot be more true, because I left college and came back when I was 29 years old. And sure enough, I followed an opportunity, followed its path, and then school was there. And so I'm very glad for you to say that, because I also tell my students there's many paths up a mountain. If you want it, take the path that's right for you. So that's fantastic. And then finally, I just want to point out, Faith, I remember the first time I collected photometric data from HG 209458, sitting at Ames Research Center, my heart going 120 miles an hour, going, I did that. Absolutely, what an incredible feeling that is. So thank you for sharing that. Julia, how about you? I mean, you've been, your cool background. I'm going to lead you up a little bit. And then, what have you been working on, and what are you starting to work on?
Yeah, thank you. I'm going to talk about Mars 2020 Perseverance mission first. This is my first job out of school. I worked on the system testbed team. So if you're familiar, for folks who don't know what a testbed is, in Apollo 13, which is one of my favorite movies, that's what Don Mattingly, edit this. Gary Sinise plays Ken Mattingly. And when he's on the ground trying to come up with enough power to power different sequences that don't use too much power to power back on the spacecraft, so for reentry, he does that in a test bed, which is hardware that is similar to the actual spacecraft and allows engineers to test that hardware, write procedures and test them before it gets on the actual spacecraft. And one of the most fun things about being on the system testbed for Mars 2020 was operational readiness tests, ORTs, as they're referred to. In aerospace, everything's an acronym. And so in an ORT, the test bed takes the place of the spacecraft. And the goal of the ORT is to train the operators. So we did dress rehearsals for launch and dress rehearsals for EDL, so that when it came to the real thing, everyone knew what to do. They've done it before. We, as the test bed, we were kind of like the person behind the curtain. We are sending the commands that the operators would transmit through the deep space network. We're secretly, sending them. And then the best part is we come up with anomalies and we'll simulate problems that happen, and then the operators have to react to it, which you can also see featured in Apollo 13. I think they would throw in alarms and then see how the astronauts react to it. So that's called being a gremlin, which was really fun. And that's not something, I learned in school or even knew was a thing, but that was about a year of my work at JPL, and it was really fun because you have to be very familiar with the spacecraft and how it functions if you're going to intentionally break it or simulate breaking it. You have to know how it's going to respond, and you have to test it a ton to make sure that you don't accidentally break something else. And you have to know the limitations of your hardware and the simulations that we have. We don't have everything. We don't have in the test bed, we actually have multiple test beds, but we don't have every single thing. So some of it is simulated, and so we have to know the limitations. So it was just an awesome way to learn about the whole system, not just, the mobility system or the cameras or the antenna. So I really enjoyed that. And we got to be involved in all of the critical events. So we have the test bed set up to shadow the spacecraft for launch and for EDL, and also for other critical flights or critical events in the mission. So I was in our test bed control area for launch, which was exciting, not just because it was launch, but because there was a little earthquake. And then, and the reason why we have the test bed set up to shadow is so if there's a problem in flight, we can quickly, it takes like the better part of a day to get the test bed set up and have all of the files on board that are on board the flight vehicle. We have to get it to match the flight state as exactly or as closely as possible. So it takes a long time. And so we want to be up and ready to troubleshoot any problems that might occur in the flight vehicle because we don't have time to set up because obviously it's a critical event. So I was also in the test bed for landing, and in the test bed, we actually fast forward, we can manipulate time in the test bed, which is neat. And so we landed the test bed a few hours before the actual landing. And that was to prove like, yes, in this flight, in this configuration that we have, so all of the operations that have been done in cruise, which is the time between launch and landing, just cruising through space on the way to Mars. If we're in that configuration, it is possible to land. So that was really exciting. And then we also had the test bed conduct the same activities, some of the same checkout activities on the first sol, which is the Martian day. So we were on the flight network talking with the flight directors, listening in. It was really cool to be involved in that. But now I am working on the Psyche Mission, which is it's a mission to a metal asteroid named Psyche, which astronomers think is the core of an early failed planet. And I'm not going to say anything beyond that about the science aspect because I don't know. There are some really cool instruments on board that we'll use to try to figure out, I guess, more of the history of this asteroid and potentially extract information about the core of our planet. There's some magnetometers. There's a there's gamma ray, neutron spectrometer, and then there's this cool technology demonstration of optical communications. So communicating with photons instead of radio waves. And so on that project, I am in the assembly, test, and launch operations team, the ATLO team, and we are the ones who actually plug everything in and build up the spacecraft and do constant testing of every little thing as each wire one by one is being connected. We do the first functional tests of the different equipment. So one of the procedures that I'm working on is the pyro functional procedure. So that's testing that there's various pyrotechnic devices to release mechanisms. So so for example, in the picture behind me, this mast, kind of like the head and neck of the rover, that's stowed during launch and landing. And it's held down with essentially bolts. But then when we're ready to deploy it, we will fire a pyrotechnic charge to sever, there are different types, but basically it'll sever that bolt. And so we can then deploy the mechanism. So it's very important to make sure that the device you're trying to release is the one that actually gets released. You don't want to try to, think you're deploying this mass and then you're deploying something else. So that's one of the things we do as part of the ATLO team. And then we also will go to Florida and be part of the countdown procedure and monitoring the spacecraft while we're launching, which is cool. Launch is happening in August 2022 on a Falcon Heavy rocket. So that's a big, powerful rocket, kind of 3 rockets strapped together. So I'm really excited for that. Yeah, that's what I'm working on.
That's incredible, man. I mean, all of you guys, what you've done in this field is just awesome. And I'm really happy to share it with alumni and as well as our current students. One quick question. What was your favorite hangout spot at ETHS and in Evanston? So Julia, I'm going to start with you.
Okay. I spent a lot of time in the Theory Center, this little room. I know it's been redone. I actually haven't seen it. I'm excited to see it, but it's a little room between chemistry and the physics classroom. I hung out there to just, work on stuff and hang out with people. I was also in orchestra, so I spent a lot of time in the orchestra room. And favorite hangout spot in Evanston. Well, I certainly spent a lot of time in Chicago at Cubs games. I went to as many as I could. But yeah, I have a twin brother, also obviously class of 2012. So hi, Remy. And I went to as many of his gymnastics meets as I could because that was really cool. I participated in the varsity track team my first few years, but then didn't continue that. I dedicated more time to like AP classes and orchestra, which was really fun. So yeah, just kind of hanging out around there.
Awesome. Yeah, for me, it was the upstairs theater. I did crew, taught me everything I knew about construction, everything like that. And then, of course, good old GGOs. That was my spot. So how about you, Faith? Did you ever have a favorite kind of hangout spot in the school or around the Chicago or Evanston area?
It's all changed so much since I've been there. I was thinking about ETHS, and I guess being the happy nerd that I was very involved with what was then the Astronomy Club. I don't know if they have such a thing anymore or not, but I hung out a lot in and or related to that through my first few years. And then I got very involved with the Civil Air Patrol, which was not part of ETHS, but they had a unit that met in Evanston in the old Quonset huts. And I don't know if they even still exist. I think they've been taken down. But that were near some Alsatian, I think. Anyway.
Yeah, it was right by Central Street, right by the where Chandler's used to be. Yeah, I grew up a block away. So.
Okay, well, they met there once a week, and I got involved with that, which took me into different parts of Illinois, since it was all the state of Illinois at the time, Illinois wing. And through CAP, I got my pilot's license, which is one of the real reasons I wanted to go
Sure.
involved with CAP. In fact, at the time, I remember seeing an article about such a thing and thinking to myself, well, I can either watch Star Trek, which was a brand new TV series at the time, or I can go join this thing and try to get there. And I get my pilot's license. And we had come from a family of pilots, so it's not unknown to us to do that sort of thing. So I went off and became more involved with that, and that took me out of ETHS more by the time
Sure.
I was getting close to graduating.
Yeah, no, I used to fly airplanes myself, and the instructor that scared the bejesus out of me, she was one of the first women's air service patrols.
Oh,
in
cool.
World War, and she was a beast. No tomfooleries or shenanigans with her. So no, wonderful. Michael, I know maybe some of the wings weren't around in 1959. I was curious, where did people hang out at ETHS or around the Evanston area? Can you enlighten us?
In Evanston was my mother's kitchen. I lived in a wonderful old house on Hartzell Street, block north of Central, and Julia must have come from Hartzell Street. Her mouth fell open there. Is that right, Julia?
Yep.
That's
crazy. We were between, my parents are between Lawndale and Highland.
That's out to the west, yeah. We were between Walnut and McDaniel, at 2329. Anyhow, so that was a great place to be. Lots of family and always something going on. On campus, like Julie, I spent a fair amount of time in the music program. And there was a place called the Student Lounge. Probably isn't there any longer. Where I think if you were a junior or a senior, you could go and pretend to be growing up and people will be there smoking and stuff. But that's a thing of the past. So those are a few memories of that era, Tom.
Well, Michael, I'm happy to report these students have many places that they can hang out nowadays. They've created a student center called the Hub. The ChemPhys, the Theory Center, has now actually been converted into a research center for all students. And so there's lots of stuff there that people can actually work on. And there's science teachers who supervise the area to help and become sounding boards for students working on longer term projects. So, and Michael, I'll say a lot of us hung out at our friends' homes and kitchens and things like that. So
can I throw in a plug for Peacock's Ice Cream and B&G? Cafeterias?
Yes. So again, I want to say thank you. There's just one last question I want to ask, and if you could just briefly kind of give it. What advice would you give to our current wild kids, thinking about their future, what they're doing now, and just how ETHS can help them in that? So let's start with Julia again.
Okay, I might need a minute to think here. I also want to mention, and I would be remiss if I didn't give a shout out to the Community Service Club. I participated in that, and we hung out in the Community Service Club office a fair amount. Okay, this is something I didn't really learn until grad school, but we all procrastinate. And if there's something you kind of consistently do when you're procrastinating, notice that and think it's not necessarily a bad thing. A lot of times that's how you know what you're really passionate about. So for me, in grad school, in 2016, I found myself not really doing as much of the research that I was supposed to be doing and paying a lot more attention to current events and issues that I felt were important, and voicing my support for them, and volunteering for different organizations. And so that is how I discovered some things that I was passionate about, because I was procrastinating. And if you like to hang out in the research center, or you're procrastinating and you're playing sports, or you're practicing your instrument instead of doing homework or whatever, just yeah, think that that's not necessarily a bad thing, and discover what you're passionate about.
So you can kind of find your internal true colors in those
Yes.
moments of avoidance of obligation and responsibility.
Yes, exactly.
Brilliantly said. Faith, what do you think? What do you think you could tell our current students today to kind of help them out on their journey?
I have two pieces of advice that I'd like to give them specifically, and I'll add a couple of things afterwards.
Sure.
The first is persistence. Persistence is going to get you a lot more than brilliance, than money, than anything else that you have. If you want to pursue a particular profession, whatever it is, it doesn't have to be science. Whatever you want to do, tenacity, just hanging in there and doing it and working toward it is going to help you to succeed. I've seen that happen over and over again through other people. I've seen it happen to me. I just hung in there when people would tell me, you can't do this, you won't be able to do this. I was in an era where I think female students were not presumed to want to do some things that I did. You can't get your pilot's license, you can't do this, you can't study astronomy, and isn't it nice that you've had a chance to do a little bit of this advanced research? You'll never probably do it again. And I would just think, well, the heck with that. I'm obviously going to do it again, and I don't care what they think because I'm going to pursue it. And it didn't much matter. If I had a roadblock, I'd work my way around it. Be persistent. Pursue your goals. Don't stop just because one person says you don't do something, or one roadblock, for whatever type of roadblock comes your way. The other is opportunism. If an opportunity comes up that would help you further along your journey as you want to go professionally, but you don't necessarily see it as exactly what you wanted, but if the opportunity comes along, for heaven's sake, take the opportunity. My personal example of that would probably be becoming a civil servant at the Johnson Space Center. When I was hired primarily to apply astronomical techniques to observing human-made debris in low Earth orbit, and geosync and geotransfer orbits, orbital debris. And trying at the very, very beginning of that field, when it was a nascent field, which is now much more quantified and advanced. It was a way for me to become a full civil servant in the place that I wanted to be. And I talked them into writing 10% of my time in to do planetary astronomy still, and kept my hand in my research long enough to finally segue back into that after a number of years of really interesting, really successful work in orbital debris. And I have no regrets about that whatsoever, but that was an opportunity that was sort of a side opportunity. And if I'd said, well, no, it's not really planetary astronomy or planetary science, I probably would have lost, the chance to do that. The same for my couple of years in South America, although I pursued getting a job at Cerro Tololo, one of our observatories down there. When they offered it to me, I said, okay, I'm going to jump the grad school world and go down and work in South America for a couple of years, because right now I can do that. I can pick up and I am free to do that, where later I probably wouldn't necessarily be so. And I got a chance to work at a great facility at the time. And then I took my backpack and traveled around South America for a while before I came back to the States. And I've never really been able to do that again. I'm glad I took that opportunity. I'm glad I stepped off of the grad school track to do that. Other pieces of advice, I thought I had a couple, now I've forgotten them. So if I can think of them, I will let you know.
Well, I'll tell you, I have two younger, well, they're not younger anymore. My son just turned 10, but Sesame Street has Bruno Mars, who sings a song called Don't Give Up. And as hokey as it is, I actually play it for my students because I can't tell you how important that is. You don't give up. You got to have that persistence. And if you see an obstacle, get around it, right? Yeah. I mean, you just do what you can.
You'll think of a way to work around it if you want to. Don't let the other people tell you what you can't do, and don't give up. Now, some of this has changed with time, and yet we're still seeing that there are issues that are coming up.
Yeah. My astrophysics, 50% are women.
And that was not the case when I was at ETHS.
Right. And that first time I saw that, I was just like, all right, we're doing something here, right? We're having an impact. So no. When
I go to scientific conferences now, a good portion, up to 40-50%, can be women at times. It's wonderful.
Great. Yeah. Michael.
Yeah, a couple of things. First of all, First of all, I couldn't have said better what Faith said about persistence and opportunity.
Mhm.
I couldn't help noticing that we have one rover on Mars now called Perseverance, and we had one which is now retired called Opportunity.
That's right.
So obviously she's onto something. I would have said it slightly differently. Follow your dreams. And I worked on the Spitzer Space Telescope for 30 years before it was launched. And we had plenty of obstacles to overcome during those 30 years. But it was the dream and the realization of what the power of this instrument would be and turned out to be that kept us going all those years.
Mhm.
Two other things. One is I want to compliment you on your astronomy and astrophysics program at ETHS. It sounds very exciting. And the last piece of advice is that unless you're really, really brilliant or eccentric or a hermit, you're going to be interacting with other people all your life. And being sensitive and respectful and understanding of what other people are bringing to the table and thinking about things from their perspective, putting yourselves into their shoes if you can, and being not being quick to criticize, but attempt to understand all these sorts of things which you might call people skills, although it sounds a little bit scheming, so to speak. But getting along with people well and working with other people is going to be a big part of your, just 1 second, a big part of your life in the future, and something you have to work on even while you're in high school. So
Yeah.
I think that's something that people should be thinking about.
No, thank you. I really, really appreciate what you guys have shared. Your journeys in the field of science and astronomy that is rooted in ETHS is just
I'm going to have to
absolutely
get off here. Sorry.
yeah. And, just kind of in closing, I just want to say, this is the start of so many people's journeys. And by watching this piece here, will hopefully inspire our next generation of scientists. And I hope, maybe 10, 20, 30 years from now, this panel is reassembled yet again with the next generation of people. So I just want to say thank you. And thanks to the Alumni Association and the foundation who got our planetarium in its current condition. And we thank it every day. And most importantly, thank all of you for helping in making ETHS and the alumni program as successful as it is. So thank you.
Again, I'm blown away. This is our 6th session of coming together, and I keep learning more and more each time we do this. Can't thank enough Faith, Mike, Julia for taking the time to be with us. Joan, we appreciate your adept facilitation and moderation of the event, and we really appreciate your taking the time to watch. If you have other topics you're interested in, please send an email to me at futranskyD@eths.k12.il.us. And as Joan said in his remarks, a lot of the money that has gone to support areas that were discussed in today's show came from the ETHS Foundation. The work modernizing our planetarium, remodeling it, and making it a 21st century planetarium, and one of the finest in the country at any high school, and the work that went into redesigning our ChemPhys labs and our theory center into a space that can be used by all science students for research and very advanced research, came from gifts from our alumni and our families and friends to the ETHS Foundation. If you want to support the foundation as we near the end of our fiscal year, please look at the graphic on the screen, and there are ways to support us that will pop up through supporteths.org. Thank you again for watching, Our next show will be the third Wednesday of May. We're working on the topic right now. Good night.